There's a dangerous myth that's deeply ingrained in software engineering, and that is that more tests always equal better quality. We are conditioned to think that if automated tests are good, then surely 100 is better than 10, and 1,000 is 10 times better than 100. So as the number of tests approaches infinity, the quality also does. So teams spend months building those big, sprawling end-to-end test suites which cover everything inside the application. Every edge case, every possible scenario, every button, every field, and every tooltip. And then the reality hits. Suddenly a simple change in the backend response or a simple tweak in the UI breaks 80 different tests across 3 different repositories. The CI/CD pipeline, which used to take 5 minutes, now takes 45. Then engineers start to ignore the failures because there's always some test failing. There's so many that at any point of the day, there's at least a couple that are failing. This in turn causes the releases to slow down, and suddenly all the dominoes fall. Because the team spends more time fixing and maintaining all those tests than actually shipping software. What I'm trying to say here is that over-testing doesn't protect your product, it actually kills your velocity. And so in this video, we're going to talk about how trying to test everything is basically a symptom of fear, what is the hidden cost of maintenance, and how true seniority lies in knowing what not to test. So first we need to reframe how we see test code, because I see this tendency in many teams where they treat test code as something that is a free asset. While when a test is developed, it will sit there and provide infinite value indefinitely at zero cost. But that is completely wrong, because every single line of code that you create is a future technical debt. It has to be maintained, refactored when the application evolves, updated when the requirements change, and debugged when infrastructure hiccups occur. So when you build a massive UI suite covering every possible edge case, you are not building a safety net, you are building a giant anchor that is going to sooner or later slow the whole team down. Because when the cost of maintaining a given test script actually starts to exceed the risk of the bug that it was supposed to catch, that test is no longer providing any value. It is becoming a liability that is actively burning engineering resources. If your team spends 3 hours fixing brittle locators or just problems stemming from those brittle locators because they have to also find out what happened, find the root cause and stuff like that. So if they spend a couple of hours of that every sprint just to validate a cosmetic page that hasn't had a substantial critical bug in like 2 years, you are losing money on that automation. So knowing all that, why do teams overtest in the first place? Why do we see test suites inflated with hundreds of redundant, heavy end-to-end tests? Because most overtesting is not driven by risk management, but instead, it's driven by fear. When a team doesn't understand the underlying architecture enough to actually conceptualize all the risks and interdependencies, or when the management has, for some reason, a zero risk policy in place, then of course the natural instinct is to just automate everything. It's what I call defensive engineering, and it's actually very, very harmful. Because look at how that unfolds usually. If a bug somehow slips to production, the natural kind of a knee-jerk automatic reaction to that is to just automate that path so that we make sure that it never happens again. So you write an end-to-end test to cover that and you think that you are safer, but the problem is that you do that again and again and again, and do that enough times. After like 50 repetitions of that, you end up with an inverted testing pyramid in your project. Because at the bottom, you have virtually no valuable unit tests, which are fast. Then you have barely anything on the integration layer, and then at the top you have a huge pile of heavy, brittle end-to-end tests validating everything. That's why it's also called the ice cream cone shape of the testing pyramid. You're basically using heavy end-to-end tests to catch basic logic flaws which should have been covered by fast unit tests or some contract testing. And those would be milliseconds fast instead of taking like 1 minute and then breaking every release. Because true seniority in quality engineering does not lie in how many tests you can write. It is measured by your ability to make pragmatic trade-offs, because everything in this profession is a trade-off. Not all features are created equal. Your core checkout flow, payment processing, user authentication, those are the critical business paths. If they fail to work, the business actually loses money or reputation, or they fail an audit. Either way, it is a big deal. So, of course, those kinds of features do warrant a heavy multi-layered set of tests so that we make sure that everything is in pristine order there. On the other hand, some secondary settings menu or some admin export tool for internal use or user's avatar cropping tool, those do not really warrant a heavy end-to-end test automation to make sure that they are bug-free. If a minor glitch happens in such low-risk territories, the blast radius is tiny. And so catching those kinds of issues through exploratory testing, unit tests, or simply monitoring production logs is vastly cheaper than covering them in the whole end-to-end suite. And you may say, yeah, but I'm a professional. I'm going to cover it like within 1 day. The problem is not that it's going to take a long time to create that test. The problem is that you are adding up to the anchor. You are adding up to the liability. You are creating something where the creation is the least of your problems. The problem is that it is going to have to be maintained for the next 3, 5, 10 years down the line. And so a senior quality engineer doesn't ask, can we create an automated test for this? They ask, what is the probability of it failing? What are the repercussions if it does fail? And what is the cheapest way to mitigate that risk? Because when you step away from the dogmatic belief that everything needs to be validated through a pre-release end-to-end set of tests, a whole new world of engineering opens up to you. High-velocity engineering teams actually rely more on post-deployment safety mechanisms rather than trying to achieve a pre-release perfection. For example, they utilize feature flags so that if something goes wrong, you only rolled out to like 1% of the users, and so you can turn off the feature flag and roll back really easily to a stable version. You just need to monitor system health, and that's basically it. The risk basically drops to 0 without the need for 50 end-to-end UI automation tests to cover that same logic. They also put kind of substantial emphasis on observability and alerting, so stuff like strong log aggregation, synthetic monitoring, and quick ways to do a rollback if something goes wrong. Those things allow you to catch and fix issues in production within minutes, very often before actual users even notice. When your deployment pipeline is fast and your rollback mechanism is reliable, the necessity for massive, slow, pre-release regression automation suites basically disappears. We need to understand that testing everything is an illusion. It's also impossible. The goal of quality engineering isn't to write the biggest test suite in the company. It's to enable the team to ship valuable, stable software in a fast and secure manner. So the next time you sit down to write a test, ask yourself honestly, am I doing that because this actually provides value to the quality, or am I doing that out of fear, or maybe just to be sure, but at the same time adding to the technical debt within your CI pipeline? And I'd love to hear your thoughts. Is your team currently drowning in massive, slow test suites, or have you somehow managed to keep it lean and pragmatic? Let me know in the comments down below, and don't forget to like and subscribe to the channel for more raw, straight to the point takes on software engineering. And I will see you in the next episode. But until then, remember to keep on rocking.